Hello YouTube viewers. Now while there are quite a few repair your laptop adapter videos available on YouTube, I'd like to give you my take on it. The first thing you should do is to determine whether or not it's worth repairing. This particular adapter was an inexpensive replacement purchased through Amazon and is available for $9 US with free shipping if you are an Amazon Prime member. So depending on what's wrong with it, is it worth waiting the few days it takes to ship and paying the $9, or just going ahead and putting in the effort to do the repairs? Some repairs are easier than others, and if it's just a broken wire, usually here or here, then the effort is not really that great. This particular adapter, as you can see, has the 2-conductor plug on it. The other type is used by Dell, Gateway, and Sony, and probably some others, but I'm just not aware of them, and has a 3-conductor plug. It has an outer conductor and inner conductor on the inside of the barrel and a pin down in the center so that the adapter can tell the laptop that yes, it is indeed a factory authorized adapter. And of course the 3-conductor plug will be a bit more difficult to repair than the 2-conductor. So now on to some troubleshooting. How do we determine what kind of fault this adapter has? In this case it's rather obvious because the outer jacket is broken right there. So next we need to determine, is it a short circuit or an open circuit? And we're going to use a multimeter for that purpose. Turn it to the ohms range, continuity, test the meter. Okay, it works. We'll go from the outside conductor on the plug to the inner conductor. No continuity, so it is not a short circuit. It must be an open circuit, most likely. So now we can determine whether or not we have an output. We'll do that. We'll go to DC volts, and we're going to plug in the adapter. And let's plug it in and see what happens. The power indicator comes on. That's a good sign. Now let's see if we get an output. No, we do not. So what's our next step? We're going to unplug the power supply and then wait for the charge to bleed off. Okay, there's been plenty of time for the charge to bleed off. Now we need to know whether or not the adapter is putting out any power. And how are we going to do that? Well, since the cable is broken right there, we're going to just go through the simple expedient of cutting off the plug. And now we want to strip the wire back. You don't really have to do a beautiful, lovely job of this. You just want to be able to get to the conductors. And get to this one here. Okay, and just by the way, this is about the crappiest thing I've ever got from Klein Tools. So don't get one of these. Okay, now we are going to plug it in again. We'll make sure that our Conductors are not touching in any way. Okay. And I'm going to take a guess that the center is positive, so we are on DC volts. That. And that. And there's our power. Good. So now we need to unplug it again and let it bleed off. So far so good. What next? Well, it's time to get radical. Now, if I had a replacement plug, I would just attach that to the end of the cord, but I don't. So what we can do is remove the plastic from the metal connection and then solder the cable back to the end. You can use your own method of removing the plastic insulation. I'm going to try these very nice side cutters first and see how that works out. Probably not too well. Of course, the next option is razor knife. Now don't worry, you won't damage the metal part. Now the razor knife works much better. It's just more difficult to hold on to. Okay, this is going to be long and dull and boring, so I'll just go ahead and finish doing this. Success! We have got the connector out of its little insulating jacket. Well, mostly. See, now's the time for the side cutters. Some of the tedious work I'm doing off camera, such as cleaning the solder points on the plug. So it's now ready for the wires to be soldered on. Likewise, I have prepared the cable. Now I wanted to get this part of the insulator as short as possible, and of course once the wires are soldered, or tinned, actually we're going to tin the wires, then we'll trim them off. They're not going to be this long once the job is complete. Now I'm ready to tin the wires. My soldering iron is heated up. Well, soldering iron in the US, soldering iron in the rest of the world. But it's hot and ready to go. Now, one of the main things about soldering is to keep the tip clean. I use this Heiko tip cleaner. You just plunge the tip in like that. Don't rake it, otherwise it could flip solder out right in your face. Plunge the tip in like that. It cleans it up. Put a little fresh solder on the tip. And then solder your wires. Okay. You want to try to limit how much or how long you apply the soldering iron so that you don't melt the insulation in here. Now the same for this wire. There we go. The wires have been trimmed and we're just about ready to install the plug. See how the wires fit just like that. Now you're probably wondering, well, what about this? It's such a short distance that trying to put heat shrink on will probably be an exercise in futility. It would shrink up from the heat of the soldering. So what I generally do is take a little bit of the outer jacket and trim it down. Don't know if you can see it there. And I'm going to slip it over this conductor before I solder the plug on. And then I can slide it up over the joint. Now we're ready to attach the wire to the plug. Debating on whether to put it on the top or the bottom. I think the bottom. Okay. Now for the top, I'm going to have to support the wire here just a little bit. Alright. Get something to push on that with. Oops, left a little point there. You don't want to leave little points. Now a wire sticking up. There we go. A fairly decent job can turn into a botched up job pretty quickly. But there we go. That looks pretty nice. And now I can slide my little ring forward. Well, I'll probably just have to do that where I can get a closer look at it. Well, there's the finished joint. Now all I have to do is put heat shrink on it. But before I do that, perhaps I should test it to make sure that I actually have power to the plug. I have the multimeter once again. We'll go to DC volts and plug in the adapter. Power indicator came on. That's a good sign. Now let's see what we get. What we get is that it won't reach. There we go. 19.36 volts. Now all that remains is to put heat shrink on it. I've cut a piece of heat shrink and slid it on there. Now it's time to shrink it. Well, the heat shrink is not real pretty, but it is functional. If you have any questions or comments, just leave them below. And as always, thanks for watching.